Hey everyone, we're going to be starting a mini unit for the next 2 weeks on microbiology, which is going to be super useful for high school. But we're going to use the current pandemic and all the pandemics that we've experienced in the past to discuss these basic microbiological concepts. So we're going to go ahead and get started with this article called History of Pandemics. We're going to go ahead and get started here with this caption over here. It says, throughout history, as humans spread across the world, infectious diseases have been a constant companion. Even in this modern era, outbreaks are nearly constant. So as you can see here, this is 2025, so 5 years from now. We can see all the outbreaks we've had going all the way back to what is that, 500? So it's just such a long time ago. As you can see, these numbers right here, these are the fatality rates. So how many people died from that during that outbreak or that pandemic. And so we can see right here. And that also is, if you look at the picture of the virus or the bacteria, the size of the bacteria connects to how many people died from that pandemic. Okay, so we can see here 200 million people died of the Black Death, which was the bubonic plague. We can see 25 to 35 million have died for HIV/AIDS. Asian flu, 1.1 million. The Hong Kong flu, 1 million. Spanish flu, 40 to 50 million. The cholera outbreak, cholera 6 outbreak, 1 million. The third plague, 12 million. Okay, let's continue. The history of pandemics. Pandemic of a disease is prevalent over a whole country or the world. As humans have spread across the world, so have infectious diseases. Even in this modern era, outbreaks are nearly constant, though not every outbreak reaches pandemic level as COVID-19 has. Today's visualization outlines some of the history's most deadly pandemics. So bubonic plague was the most deadly pandemic. The plague originated in rats and it spread to human via infected fleas. This happened in 1347 to 1351. So this pandemic actually lasted a solid 4 years before they started to see a shift. Then we have smallpox, the Spanish flu, and the plague of Justinian. The outbreak, so we're back to the bubonic plague. The outbreak wiped out 30 to 50% of Europe's population. So half of Europe's population died during that pandemic. It took more than 200 years for the continent's population to recover. So this made a huge dent, and it took Europe a very long time to bounce back from that. Okay. A timeline of historical pandemics. Diseases and illnesses have plagued humanity since the earliest days, our mortal flaw. However, it was not until the marked shift to agrarian communities that the scale and spread of these diseases increased dramatically. Widespread trade created new opportunities for human and animal interactions that sped up such epidemics. So when they're talking about trade right here, they're talking about how as countries and continents began to industrialize, they began sharing their resources and they began trading their resources across oceans. And so when countries started sharing their resources and started traveling across the globe, they were carrying these diseases from their various pockets and spreading them to other places where they were not already there. The more civilized, malaria, tuberculosis, were right here. Malaria, tuberculosis, leprosy, influenza, smallpox, and others first appeared during these early years. So as we started to trade more often, as countries became more established, they started to notice way more cases of these infections. The more civilized humans became with larger cities, more exotic, the more civilized humans became. So as we became more established in our areas, larger cities came in, more exotic trade routes began to form, and increased contact with different populations of people, animals, and ecosystems, the more likely pandemics would occur. So as these, trade routes were being formed, people and animals were interacting that were never interacting before. There were people from the Americas that were interacting with animals and food products all the way from rainforests over in Africa and Asia, and those interactions had never happened before. So it's natural and it's logical that these infections would also start to transfer over. Here are some of the major pandemics that have occurred over time. These pandemics are also in this image up here and this image here, just in a different format. So here we can see the name of the pandemic, the time period, if it was the source, so if it was a virus or a bacteria, and if we are aware of the pre-human host, that is listed here. So for example, for the smallpox in Japan, from 735 to 737, this was a virus that caused a fatality rate of 1 million people. They do not know the pre-human host, which is why that is not listed here next to virus. But for the Black Death, which was the bubonic plague from 1347 to 1351, again, 200 million people died during that. That was a bacterial pandemic, and it did start in rats and fleas before it transferred over into humans. Now, connecting to the natural selection unit, the transferring of this bacteria from a rat or a flea to a human is only possible because of a random mutation. So normally that bacteria would not survive in a human host, but they're, as we know, as bacteria, animals, plants, when everything reproduces, there is a chance for a random error. And if that random error occurs in the exact right spot, which makes it possible to transfer this to a different species, then that's where this becomes a problem. And that's exactly what happened with COVID-19. This specific strain of coronavirus was not normally infecting humans. And then what we're guessing is that there was a mutation that then allowed it the opportunity to infect other species, such as humans. Importing diseases. The practice of quarantine began during the 14th century in an effort to protect coastal cities, so cities near the water, near the oceans, from plague epidemics. Cautious port authorities required ships arriving in Venice from infected ports to sit at anchor for 40 days before landing. So what that means is that the ship would have to anchor a certain amount of space out off the coast, and no one would be allowed off the ship for 40 days before it could actually dock at that coast or that port. The origin of the word quarantine comes from the Italian quaranta giorni, or 40 days. One of the first instances of relying on geography and statistical analysis was in mid-19th century London during a cholera outbreak. In 1854, Dr. John Snow came to the conclusion that cholera was spreading via tainted water and decided to display neighborhood mortality data directly on a map. This method revealed a cluster of cases around a specific pump from which people were drawing their water from. While the interactions created through trade and urban life play a pivotal role, it is also the virulent nature of particular diseases that indicate the trajectory of a pandemic. Virulent nature means how infectious is this virus? How contagious is it? What is the R0 score? And we're going to talk about what R0 stands for in just a minute. Urbanization and the spread of disease. We arrive at where we began, with rising global connections and interactions as a driving force behind pandemics. From small hunting and gathering tribes to the metropolis, humanity's reliance on one another has also sparked opportunities for disease to spread. Honestly, I just don't think like there may have not been a way to avoid this, right? As a developing global economy and global societies, like we all had to do what we needed to do in order to survive and to industrialize and urbanize the way that we have. And I think it's just about figuring out how to respond. This might have, as humanity on the planet is getting smarter and more intellectual and more technology savvy, like these things, you know, it was hard to avoid. Urbanization and the development in the developing world is bringing more and more rural residents to denser neighborhoods, while population increases are putting greater pressure on the environment. At the same time, passenger air traffic nearly doubled in the past decade. These macro trends are having a profound impact on the spread of infectious disease. As organizations and governments around the world ask for citizens to practice social distancing to help reduce the rate of infection, the digital world is allowing people to maintain connections and commerce like never before. So now we're going to talk about tracking infectiousness. So scientists use a basic measure to track the infectiousness of a disease called the reproduction number, also known as R sub 0, which is right here, or R naught, NAUGHT. So R sub 0, R naught, and reproduction number are all the same thing. This number tells us how many susceptible people on average each sick person will in turn infect. So they talked about this number at the beginning of the COVID-19 pandemic. They were telling us that on average, if someone gets sick with COVID-19, they could infect 2.5 people. Just by if the population is unvaccinated. So they get that number by a series of statistical analyses and just plugging in data to generate this number. So if you take a look at this really cool graphic, it shows you the R naught for certain diseases. So we have MERS, we have influenza, which is just the regular flu, Ebola, SARS, mumps, rubella, smallpox, and measles. Now, some of you might have, a lot of people, need to get vaccines. You might remember a vaccine that you've taken called the MMR vaccine. That stands for measles, mumps, and rubella. So it's one shot, and you get vaccinated for all 3 of these diseases. Now, the cool thing about this is these diseases have come and gone, and we've been able to create vaccines because they've showed up. And now we can pretty much eradicate these diseases from our lifestyle because the vaccines are working and they protect you against these viruses and bacterias. So as you can see, if someone is infected with MERS, they can infect 0.8 of a person. So again, this is like, how do you infect 0.8 of a person? But it's just a statistical analysis number. So what this tells you is that MERS is not very infectious or contagious. It's still contagious, but not as contagious as, let's look at the measles. So an infected person with the measles could infect 16 other people if the population was not vaccinated. Now that is a huge number. So what that means is for every one person, they can pass it on to 16 other people. So in an unvaccinated population, that's a really scary number. And so this was the low, this is the high, and you can see all the in-betweens, okay? Measles tops the list, being the most contagious with an R naught range of 12 to 18 people. This means a single person can infect, on average, 12 to 18 people in an unvaccinated population. Now, if the population is vaccinated, then this number no longer is in effect because each person has immunity, and we're going to talk about what immunity is in this unit. Because of the vaccine, it gives the person immunity. It's basically like exposing the person to the vaccine's DNA so the body can remember that DNA without getting actually sick. While measles may be the most virulent or infectious, vaccination efforts and herd immunity can curb its spread. The more people are immune to the disease, the less likely it is to proliferate.